Hey guys, we've got another easy day ahead of us. So now we're going to review some types of equations, starting with linear. So this is a linear equation. It's just a straight line. Now we write equations in several different ways. X plus y equals 8 is this particular line, and that's written in standard form. Now standard form is ax plus by equals c. And here's some conditions that must be met. But let's talk about what it actually means. First, a's got to be positive. So no negatives here. Second, you can't have any fractions. And third, a, b, and c can't have any common factors. So if 2 goes into a and b, it cannot go into c. C's got to be out. So they can't be able to be divided by the same thing. If it is, it's not standard form. You got to simplify it. And that's what all this means. So just remember, positive, no fractions, no common factors. And this order, ax plus by equals c. And this plus by, that doesn't have to be positive. It could be negative. So let's just do it. Let's make these standard. So what are the conditions? First, ax plus by equals c. So that's the right order of things. Now, a's got to be positive. We don't care about b, but a has to be positive. Since it's not, we're going to multiply through by a negative. So we're going to multiply each term by -1. It's not -1, we're actually multiplying here. So I'll put it in parentheses. And you don't actually have to write out the step, because if you think about it, all it's going to do is change the signs. That's going to be positive 5x minus 6y equals a positive 12. Now let's check. Do we have any fractions? No. Is a positive? Yes, it is. Do we have any common factors? Well, look, 6 and 12 both have 6 in them, but 5 doesn't. 5 doesn't have any common factors with those, so we're good to go. Here, this one's in a different form that you should be familiar with. We'll talk about it soon. Let's rearrange this equation. So we need ax plus by equals c, and x has to be positive. So I'm just going to go ahead and subtract y from both sides. And I'm also going to add 9 to both sides. Okay, I'm doing two things at once here, but let's see. Y minus y is 0, plus 9 is 9. We bring on the 2x minus y. 2x minus y, well, that's just 2x minus y. If you have 2 dogs and I kill one of your cats, you still have 2 dogs. This isn't quite standard form. Let's look. Ax plus by equals c. So we've got to use a symmetric property and rewrite this. Yes, back to those properties from geometry we talked about. We're just going to flip this. 2x minus y equals 9. Let's check again. A is positive, that's good. It's in the right order, and there's no fractions, and, well, that's a 1, so obviously there's no common factors. Let's do this one here with a fraction. So same thing as always. If we got a fraction, get rid of them first. To do that, we're going to multiply by the LCD, which in this case is 4 and 3 makes 12. If we just multiply those together, that'll work. So I'm going to multiply through by 12 to each term. Excuse me. So I'm just kind of cheat right here and write it out up top. 12, 12, 12. So I'm multiplying each of these by 12. I'm going to go ahead and simplify it here. 12 divided by 4, well, 4 divided by 4 is 1, 12 divided by 4 is 3. So that's going to be 3 times 3 in a second. 12 divided by 3 is 4. All right, that's as simple as we can do it. 3 times 3 is 9. Don't forget the x. Minus 4 times 1 is 4. And don't forget the y. Equals, and then 12 times 1 is 12. Let's check. Well, the 9 and the 12, they both have 3 in them, but the 4 doesn't, so that's good. No common multiples there. A is positive, there's no more fractions, and it's in the right order. We're good. I'm going to go back and let's do this one. So I'm going to add 7x to both sides. I want to write my x's first. I mean, you can add whichever way. 2 plus 3 is the same as 3 plus 2. We do 7x plus 7y. That needs to equal 7. So let's see. Positive, no fractions. It's in the right order. But look, all of them have a 7 in them. So I need to divide each and every one of these by 7. X plus y equals 1. All right, so same process for all of these. This one you just add 24, and then you have to divide by the common factor. But it shouldn't be anything new there. All right, so slope-intercept form. This is probably what most of you are used to when talking about linear equations. Y equals mx plus b. M is your slope, b is your y-intercept. Okay? Now, there are 4 types of slope. So let's go ahead and make that. 4 types of slope. And we're going to sketch them. So we got a positive, negative, 0, and lastly, an undefined. Yes, undefined is a thing. I want you to think for a second. Positive and negative slopes. So what matters is whether it's going up or it's going down. Now, we live in America. In America, we read left to right. So read left to right. So if it's going up from left to right, that's a positive slope. So if it looks something like this, it's increasing. If we're going from left to right, it's going up. Negative's going to look something like that. 0, well, that looks like that. Undefined looks like this. So remember, slope is your rate of change. You might remember it as rise over run. So on these, it's a positive rise over run, a negative rise over run. Here, let's think about it. Our y is not changing, so we're rising 0. No rise over whatever run, that's 0 divided by anything is just 0. That's why it's a flat horizontal line. Now this one, we're not running at all. We have whatever, anything, doesn't matter, divided by 0 is, yeah, good question, can't tell you. It's undefined. So let's do a couple of these. So yeah, function notation is still a thing. Remember, y is your output, f of x is your output, g of z, whatever your function is, whatever your function's name is, whatever your input's name is, doesn't matter. This notation, function notation, just means y. So we want it in slope-intercept form. They're done. So let's write down our slope and our y-intercept. Now let's use that to graph this thing. So b is 7, so I'm going to put a dot on 7 on my y-axis. It's my y-intercept. 1, 2, 3, 4, 5, 6, 7, right there. Now my slope is 2 over 5, so I could go up 2 and write 5. It's rise over run. That's going off my graph, so I need to change it. Some other way I need to be able to write it. Let's think. 2 over 5 is the exact same as negative 2 over negative 5, right? Negative over negative cancels to positive. See that? These are the same. But if we interpret it in terms of rise over run, we're rising a negative 2 down 2 and running a negative 5. So it'll be negative direction, left 5. So I'm going to go down 2, left 5. And there's my dot right there. Now you could go down 2 and left 5 again, except it's going to be off the graph. Doesn't really matter. It says to graph the line, so go ahead and grab your line drawing tool. Yes, you have one. And do something like this. Right. Hear that. So these are lines. They do go on forever. Might as well mark some arrows on the ends. I'll just mention the slope here. It's negative x, so that's another 1 there, so that's negative 1. We'd write that as negative 1 over 1, so we can read it as a fraction. Or 1 over negative 1. So there's your options. Your b, your y-intercept is a 2. You plot it, go down 1, right 1, or you go up 1, left 1. Your choice. And you draw it. Nothing much interesting here. Let's do number 10. It says to write it in slope-intercept form. So this is not in slope-intercept form. We have to solve for y. We need to get y by itself. So I'm going to subtract 4x and add 1. Y equals a negative 4x plus 1. Done. All I do is subtract 4x for both sides. I added 1 to both sides. And that's what we came up with. And it's negative 4, which again we can put over 1. And the y-intercept is 1. Again, these should be extraordinarily familiar to you. I'm not going to hammer this too much. If you need more practice, let me know. But let's look at horizontal lines and vertical lines. Okay. Write the equation to represent the line shown in the graph. So we got this line right here. It's a vertical line. So what's always the same? Well, my x value is always the same. It's always negative 3. So x equals negative 3. Well, look at this one. My y value is always the same. It's always 1. So y equals 1 is that equation. So if we look at parallel lines, they have slopes that are always equal. So two vertical lines are parallel. They all have undefined slope. Boom. The slopes of perpendicular lines are negative reciprocals. So perpendicular, remember, they intersect at right angles. But algebraically, the important thing to remember is that their slopes are negative reciprocals. That means if you multiply them together, they equal negative 1. So let's do an example. Let's say y equals negative 2/3 x minus, who cares what? That doesn't matter. That's the intercept. Here's my slope, negative 2/3. If we have a parallel line, these bars mean parallel, a parallel line, then its slope would be the same, negative 2/3. Perpendicular, that's represented by an upside down T. Perpendicular. That's a negative reciprocal. That means you reciprocate, you flip it, and change the sign. That's going to be positive 3/2. And you can check. Take your calculator. Clear this. Negative 2/3 times, what did I say? 3/2. Let's see. And if these are perpendicular slopes, that better equal a negative 1. If it doesn't, something's wrong. Oh, look, it does. We're good. They're negative reciprocals. That means they're perpendicular. So, for example, this could be 3/2 and that could be negative 2/3. Is it? I don't know. I just randomly rotated that. Doesn't matter. So let's look at a couple of these. If we notice, these are in standard form or some random form. You can always solve for y to get your slope. So if I solve this for y, sorry guys, it's coffee. 5y equals negative 10x, and we really don't care what this is, plus 5. Divide y equals negative 2x plus 1. Again, we don't care about that. Over here, I'm going to just swap that around a little bit. 2y equals negative x minus 16. That's negative x. Let's cover it up. Negative x minus 16. I subtracted 16 from both sides and swap the sides. Divide by 2. Divide by 2. Y equals negative, and we can split this up. That's negative x is 1x, so that's negative 1/2 x minus 16. Compare the slopes. Negative 2, negative 1/2. Are they the same? No, not parallel. Are they negative reciprocals? Well, I'm going to tell you no right now, because look, they're both negative, so they're going to make a positive something if I multiply them together. But you could always test it. Negative 2 times negative 1/2. And we get positive 1, not negative 1. So this is neither. This is neither parallel nor perpendicular. Yeah, why not this one? So if I solve for y, 8y equals 8x. Well, 0 doesn't matter. Divide by 8, y equals x. Solve this one. Negative y equals x, negative x minus 4. Plus 4, sorry. I subtracted x from both sides. Divide through by a negative, just change all the signs. It's going to be positive x minus 4. So if I look at my slope here, it's how many x's? 1 x's. How many x's? 1 x's. These are the same. 1 is the same as 1, so these are parallel. Now if you think about it, this is a vertical line. This is a horizontal line. Obviously, they're perpendicular. But if you think about their slopes, this is a 0 slope. This is an undefined slope. Now, if we reciprocate 0, that's 1 over 0. Well, what do you get when you divide by 1 divided by 0? Undefined. Okay, moving on. So the point at which the graph intersects the axis is called the x-intercept. So if it crosses either axis, that's an intercept. X-axis is x-intercept, y-axis is y-intercept. Now this number right here, the x-intercept, has a lot of names, and it's usually what we're looking for. We can call it a root, a 0, or a solution. Or we can call it the x-intercept. Now if you're looking on a graph, it's easy to see, oh hey, there's my x-intercept, there's my y-intercept. But what if you're looking at an equation? Well, if we look right here, my x-intercept has a y value of what? 0 every single time. Everywhere on this x-axis, my y value is 0. So if I plug in 0 for y, or f of x, or whatever the function's name is, then solve it, that's going to give me my x-intercept. If I plug in 0 for x, that's my y-axis giving my y-intercept. And if it's a function, you better only have one y-intercept, but you can have multiple x-intercepts. Here's an example. Y equals negative 2x plus 5. Find the x-intercept and the y-intercepts. X, y. For x-intercepts, you plug in 0 for y. 0 equals negative 2x plus 5. Again, setup and solution, that's all I need from you. From there, you can tell me that x equals 5/2. However you want to do it. You can actually do math, you can take it in a calculator, whatever. that? Yep, 5/2. Now the y-intercept, we plug in 0 for x. That's y equals, or f of x equals, whatever you happen to have here. Again, plug in 0 for x, and we get y is 5. Hopefully you can do that without a calculator. 0 times anything is a 0. So 0 plus 5 is 5. Okay. So find the x and y-intercept for each equation in the graph using the intercept. So y-intercept, -1. X-intercept, well, I got to add 1 to both sides and divide by 5, so that's 1/5. That's terrible. Why would they want us to do it this way? I don't know. We can. Y-intercept is -1. X-intercept is 1/5, which is like right there. And you just graph it. So something like that. Okay. Oh, if you need me to solve this one, just 0 equals 5x minus 1. Add 1 to both sides. Divide by 5. 1/5 is not the same as 5. Let's look at this one. My y-intercept. Plug in 0 for x. This is just ignore this. That's 2. 0 times anything is nothing. 0. 0 plus 2 is 2. Easy. For my x-intercept, I'm going to need to work it out. 0 equals -6/5 x plus 2. Again, set it up in solution is all I need. So you can take this and type it in your calculator. If not, it's a basic freaking linear equation. You should be able to do it in your sleep. LCD, combine like terms, isolate your variable, yada, 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 you're done. So just type it in there. And I get that. So I don't want decimals, obviously. I just hit the X and hit equals, and it gives it to me as a fraction, 5/3. Thank you very much, calculator. So again, that's a nasty way. Y is 2, that's like right here. 5/3, that's between 1 and 2. So closer to 2. So put it right there. Draw a line. And you probably know what I'm doing right there. I'm just counting the slopes so I get a nicer line going through these. Otherwise, I might be pretty off. I'm bad at guessing like that. Nothing different there. Same thing, same thing. Let's see number 6 because it's got a lot of fractions and y'all hate those. So again, LCD, first thing. 4 and 3 is 12. So multiply 3 by 12. That simplifies. That simplifies. 9x minus 4y equals -24. For my y-intercept, x is going to be 0. So take your hand and cover up the x's, just the x's. Pretend this thing isn't there. In fact, I don't know, whatever. Oh, I put the letters here. Okay. Frozen much? Oh, yeah, it doesn't work with the text. Sorry. So pretend this isn't there. So ignore this entirely. You get -4y equals -24. All you have to do is divide by -4 and you get y is 6. Similarly, for the x intercept, pretend that's not there. So 9x equals -24. Well, that's not too nice. It's going to be -24 over 9, but both of those have a 3 in them, so that's -8 over 3. And we have to plot that mess, but I don't feel like it. If you're not sure exactly where it goes, type it in the calculator. -8 thirds is about 2 2/3. It's a 2 in the middle. It's -2 2/3. So it's a little bit less than -3. So you plot that to the small. You plot that. Connect the dots. So, moving on. Oh, that's it. All right, guys. Practice those. Rewrite with slope-intercept form if you need to get the slope. If you need to write it in standard form, just rearrange it, make sure A is positive, no fractions. And of course, you have the DCF as 1, no common factors there. Let me know if you have any questions.